All right. So in this lesson, we are going to learn what does it mean to have inverting operations. So we're going to have two objectives. Objective number one is we're going to determine all input values that correspond to a specific output value given a function model on a specific or a specified domain. And then our second objective is actually going to be something new that we're going to tackle today, or maybe tomorrow. We're going to express exactly or approximately the value of a logarithmic expression as a rational number. Now, sometimes we won't be able to do like an exact rational number. That's why we're approximating as well. Now, one of the things that as I was, creating the notes today, and as I was thinking about the examples, and I was looking back on some of the things we've already worked through, we have not even defined what a function is. I went through our notes where I thought we might have seen it, but the reason that we're going to be defining what a function is because some of this terminology and language is going to show up in this lesson and in lesson 4 when we talk about something else, but I'll save for them. So how we define a function is really important because it can be used. This definition of a function can be used in a lot of different scenarios. Okay. So a function is you could put two words here. You could either say it is a pattern. Whoa, what just happened there? It's a pattern. You could also put it's a rule, right? A function is when we take a look at a set of numbers and we're noticing that it is following a pattern or a rule. Now, when we think about a function, what are some other phrases or words we see when we talk about a function? And maybe even think about like how we complete this definition. It's a pattern where one element of the blank is assigned to blank element of the blank. What kind of words, when you think about function, or maybe I'll even throw out there function notation, what are some words that we use when we think about a function? I'll tell you two of the words come in a pair. So if I tell you one, you're going to know what the other one is. Yeah.
So like input.
It is a pattern where one element of the input is assigned to blank element of the output. Oh my word, what's happening here? Output. Okay. Now, what do you think this other blank is going to be?
Missing.
Ooh. Wait, what'd you say?
Like missing.
Missing, where one element of the input is assigned to missing element. Not quite. A function is a pattern where one element of the input is assigned to one element of the output. Now, what is another word? What's another pair of words we could use instead of input and output? What I do think is the best way to think about a function. First, I'll give you the first letter of this first one. D. Domain name range. Okay. Back in the day, we would also talk about like independent variable, dependent variable. That language is not seen as often, but we can think about independent in the same way we think about input, something we're plugging into the function, and dependent meaning The y's are dependent on the x, right? So a function is a pattern or a rule where one element of the input is assigned to one element of the output. Now, here is something I'm going to tell you now, and we'll talk about this maybe later on this year and next year as well. The vertical line test that we talk about like in algebra and stuff like that. And I've disposed of this there. The vertical line test is a bad test because there are you don't need to write this down. There are graphs that look like that. They are a function. Because if I look at this in a table, it fits a pattern where one element of the input is assigned to one element of the output. Just how it is seen graphically, it doesn't look like a function. So we're disposing of the vertical line test. Knowing the definition of a function can take us pretty far. Okay. Now, and the reason that we're talking about this now is because with some of the equations and problems that we're going to be solving today, we'll be talking about input and output. Okay. All right. So an inverse operation, we're going to define this as the process in which you undo an operation. It's the process in which you undo an operation. So think about all those times in algebra, or even like last year in geometry, when you were solving an equation, you are inverting different operations within those problems. Okay. So let's talk about, we're going to see some basic ones today. We're also going to look at some things with a graph, and then we'll get to what in the world is a logarithm. Okay. And we'll also talk about logarithms in Unit 3 as well. So, all right. So, example 1. Given the following functions, g and f, so I've got a square root function and a linear function. Solve the following equations. Now, you might be thinking, well, Mr. Hall, you're giving me function notation with these equations. Remember, an equation is an algebraic representation connected by an equal sign. So let's look at A. A is saying that g of x is 9. When you see g of x or f of x or anything else down here, I want you to remember that this g of x, this is talking about the output. This is talking about the output. So I'm saying when we solve for the following equations, we are taking g of x, which is the square root of x. We want to see where is the output 9. That's what this is saying. When is the output 9? Well, to do this, I can plug in that square root of x. So then how do I undo the square root? Square. Square this side. Square this side. The square root and the square cancel out. X is 81. That is a simple example of how you do an inverse operation. You're undoing that work. One thing that's coming to mind is SandMap. When you were solving equations, this is what you're doing. Okay. One thing that you'll see as we work through things more like conceptually, we'll like explore something and then we like put terms on it. So like each of these equations, you know how to do. Just in the past, we didn't like give it this formal language. Okay. B. So in this case, g of x is 4/5. So what would be the answer to this equation if the square root of x is 4/5? If we square each side. What's 4 squared? And 5? So we can undo square roots with squaring. We can undo squares with square rooting, okay? So square roots and squares go together. Now let's take a look at this f of x, x plus 3. So again, f of x is talking about the output. X plus 3 is 8. How do I undo that plus 3? Minus 3. Minus 3. X is 5. X plus 3 equals negative 10. Minus 3. Minus 3. X is negative 13. Okay. So with each of these, we can be thinking about, what am I doing to undo the operation that I'm seeing? This is the algebraic way of how you would do it. Now, let's think about it graphically. So, I have a particle moving at a velocity of v of t, which is t squared minus 4t plus 6. We're going to find where does the particle